Okay, so first we're going to talk about what causes Earth's weather and climate, because it's going to be the weather and climate that is going to shape landform development on the Earth's surface. So let's first talk about the structure of the Earth's atmosphere. So we're only going to be interested in three of the Earth's layers. So we're going to talk about the troposphere, we're going to talk about the stratosphere, and then we're going to talk about the ionosphere. So let's first talk about the lowest level, which is going to be the troposphere. So all of Earth's weather is going to be taking place in the troposphere. So if it's raining, when we talk about surface winds on the Earth, that is in the troposphere. So this is a picture of a very severe storm in Oklahoma, and you can see how the clouds have boiled up and then it's flat on the top. So we call this an anvil cloud. So what has happened is the clouds have risen as high as they can in the troposphere, and then when you get to the stratosphere, they can't go up any higher. We're not going to get into why that's true, but just take it from me that clouds don't rise into the stratosphere. So they have to go somewhere, so they're going to go sideways. So if a cloud can do this, then it's got a lot of energy. And so if you ever see an anvil cloud, then you probably need to be taking cover, because that storm is going to be pretty severe. Now, above the troposphere is going to be the stratosphere. And the stratosphere is going to be the place where the jets fly. They fly up there because it's relatively calm. Okay, the stratosphere is going to have the ozone layer. So let's talk a little bit about what we mean by that. What you breathe is O2. So two atoms of oxygen bonded together that's molecular oxygen. That's what you breathe. Ozone, on the other hand, is going to be O3. So it's got three atoms of oxygen that are bonded together. So what happens up in the stratosphere is ultraviolet light comes in from the sun, and it's going to strike the ozone layer. And so when that ultraviolet light, so UV light, comes in and it hits this, then it's going to break it up into O2 and then another atom of oxygen. And this other atom of oxygen is very reactive. And so given enough time, what will happen is those two will go back together again and turn back into O3, and it will give off infrared light. So the energy that came in was ultraviolet, which is bad because that can give you skin cancer and sunburns, but it changes it into infrared, which is heat. So that's the purpose of the ozone layer in the stratosphere. Now the problem, though, is that way back in the 1940s, we used these things called CFCs, and that stands for chlorofluorocarbons, to make air conditioners with and to make aerosol propellants with. And the problem with that stuff was that, let's say that you had an air conditioner that conked out on you, and then you would call the repair person. They would unscrew the cap, they would pour in some more Freon, then they would cap it back off, and away you'd go. And they would just let all of that other stuff just go into the atmosphere. And it took something like 40 years for those pollutants to get up into the stratosphere. Well, because they are chlorofluorals, chlorine and fluorine, they're very reactive. And that means that they can destroy ozone molecules. And for every molecule of CFC, it can destroy something like 1 million molecules of ozone before it itself is destroyed. So It's a very bad thing that all of these chemicals are up in our stratosphere, and it's going to take something like another 40 years for the ozone layer to completely repair itself and to neutralize all of those chemicals that are up there. Okay, so I'd like for you to watch this little video, Sea Climate 101, Ozone Depletion by National Geographic on YouTube, and that will help explain a little bit more about the ozone layer. Okay, let's take a break, and when we come back, we will talk about the ionosphere.